All right, let's just jump right in. What we're witnessing right now is a high stakes war for the future of technology itself. And it's being fought on a scale so small, it's almost impossible to even comprehend. We're talking about the battle for the 2 nanometer chip. And right at the heart of this fight is an absolute titan of the industry, fighting for its very survival: Intel. To really get a handle on what's at stake, you just have to look at this one number: 2.5 billion. That's the operating loss for Intel's brand new chip-making division, Intel Foundry. And that was just for 1 quarter. Nope, that's not a typo. It's an absolutely staggering figure that tells you just how deep of a hole they're starting in. And look, this isn't just me or some analyst saying this. This is a direct quote from the CEO, a really stark admission of the problem. They basically built these incredible world-class factories, but they're still scrambling to find enough customers to actually fill them. So the big question is, why? So in this explainer, we're going to break it all down. We'll kick things off with Intel's billion-dollar problem. Then we'll uncover this impenetrable moat that protects its biggest rivals. We'll take a look at the 2 nanometer battlefield, analyze the super narrow window Intel has to make this work, and then dive into their high-stakes gambit. And finally, we'll look at the two possible futures. They either win or they fold. So what is Intel's core problem, really? Well, it's not a lack of cool tech, not at all. It's the huge gap between having that technology and convincing the rest of the world to bet their own billion-dollar products on it. To really understand that gap, you've got to understand the moat. See, the chip-making business, what they call the foundry business, is just notoriously incredibly difficult to break into. Let's look at the three big invisible walls that protect companies like TSMC. Okay, so the first wall is something called the PDK, or Process Design Kit. The easiest way to think about it is like a universal translator. It takes a chip designer's brilliant idea and turns it into a physical blueprint for the factory. It's super complex, and if that blueprint is off by even a tiny little bit, a customer's multi-million-dollar chip design, well, it just plain won't work. And this right here is where the magic happens for the market leader TSMC. It creates this powerful self-feeding loop. See, the more customers you have, the more real-world data you get from their actual chips. That data lets you make your simulation models, your PDKs, insanely accurate. That accuracy builds trust, which, you guessed it, brings in even more customers. It's this virtuous cycle, a flywheel, that's been spinning and picking up speed for decades. And Intel, well, they're trying to get their flywheel started from pretty much a dead stop. The second wall is what's called BKM, or Best Known Methods. This is the real secret sauce. For every single one of the thousands of steps it takes to make a chip, there's a perfect recipe: the exact right pressure, the exact right temperature, the timing, all of it. And you don't learn this stuff in a lab. You learn it by running millions and millions of wafers for hundreds of different customers. It's earned knowledge. Now, all of this, the PDK, the BKM, it all boils down to one critical metric: yield. This is, simply put, the percentage of perfect working chips you get off a single silicon wafer. And it is, without a doubt, the single most important number in this entire business. Now, just look at these two bars. They show how a difference in yield that might seem small has this just astronomical impact on cost. A single wafer costs over $20,000 to make. So if your yield is only 67%, your cost for each working chip is huge. But if you can just push that up to 90%, your cost per chip plummets. This is the brutal, unforgiving economic reality that Intel is facing. And that brings us to the battlefield for the next generation of chips, the 2 nanometer node. Right now, there are really only 3 major players left in this game. So here's a quick tale of the tape. Intel's process, called 18A, is betting everything on a brand new technology called PowerVia. But look at the density. TSMC's N2, which uses a more traditional approach, can pack way more transistors into the same amount of space, and more density usually means cheaper chips. Then there's the ecosystem. TSMC is the undisputed industry standard, while Intel's is, just getting started. This slide just perfectly captures the core strategic difference here. It's revolution versus evolution. Intel is making this massive, radical bet on backside power delivery, or PowerVia. It's a revolutionary idea, and it promises way better performance, but it's incompatible with almost every existing chip design out there. Meanwhile, TSMC is taking the safe, evolutionary path. They're sticking with the tried and true method for now, making sure their thousands of customers don't have to redesign everything from scratch.
And hey, let's not forget about the third player here, Samsung. They're both a cautionary tale and a serious threat. I mean, they stumbled, and stumbled badly a few years ago, but now they are fighting their way back. They're competing on price, and they're landing huge deals, like a reported $16.5 billion agreement with Tesla. They're trying to become the other credible alternative to TSMC, which is exactly the spot Intel wants for itself.
All this competition creates this really profound sense of urgency. For Intel, the window of opportunity is definitely real, but man, it is closing, and it's closing fast. The next couple of years are absolutely positively critical.
Just look at this timeline. As it stands today, Intel's single biggest advantage is being the main game in town for high-end chip making on US soil. But in 2026, Appia is going to make its big go or no-go decision about using Intel. And then, by 2027, both TSMC and Samsung are slated to have massive new factories up and running right here in the US. That's going to completely wipe out Intel's key geopolitical edge. The clock is seriously ticking.
So what's Intel's plan? What's this high-stakes gambit they're trying to pull off inside this closing window? Well, it all comes down to two things: customers and execution.
The biggest prize, the white whale, is Apple. Landing even a small piece of Apple's business would be a total game changer. It would give them the volume and, maybe more importantly, the validation that Intel so desperately needs. And the timeline here is incredibly tight. The key inflection point, that moment of truth, is going to come in the first half of 2026.
And then you've got NVIDIA, and they are playing this very, very smart. They're planning to keep their most critical part, the core GPU, with the proven winner TSMC. But they are considering letting Intel make a less critical I/O die. It's a really low-risk way for them to test the waters with Intel. But the crucial part here is the side door. NVIDIA might use Intel's world-class packaging technology, which would give Intel a real foot in the door. So for any of this to actually happen, it all just boils down to execution. Intel has to clear 5 critical hurdles. 1. Prove the yield on their own chips first. 2. Ship their process to customers on time, no delays. 3. Establish a real tech advantage with their next-gen process, 14A. 4. Use their packaging advantage as a wedge to get customers in the door. And finally, 5, they have to execute now. They have to turn all that government support into real results before their rivals catch up to them on US soil. So if they do all that, what happens? And what happens if they don't? This brings us to the two very, very different futures that are facing Intel Foundry.
The bull case, the optimistic view, is that the flywheel finally starts turning. Apple and NVIDIA sign on for real volume. That volume helps them learn faster and drives up their yields. Their next technology, 14A, puts them in a true leadership position. The massive financial losses start to shrink, and Intel becomes the credible, powerful second source to TSMC that the entire world really needs. But the bear case is just as plausible. Schedules slip again. The technology isn't mature enough. Apple says, thanks, but no thanks. NVIDIA plays it safe and sticks with TSMC. That US advantage just evaporates as their competitors' factories come online. The foundry keeps burning through billions and billions of dollars, and eventually the company is forced to retreat, ending what would have been one of the most ambitious turnarounds in the history of tech.
So in the end, it all comes down to one thing. The technology? It's real. The strategy? It's clear. They've got geopolitical tailwinds at their back. But that window, it is undeniably closing. The only question that really matters now is also the hardest one of all. Can Intel execute?